the third period, I recorded a page that never moved. Cool. Okay, so matching these up, you guys were pretty good with, if it's inside the function, that moves something left or right. How do you tell which way? Well, this is what I think in my head, whereas this one, I already have the y equals 4 less than it used to be. So this is left 4 units, this is down 4 units. This is right 4 units, and Jonah said that negative inside there reflects over the y-axis. This reflects over the x-axis like this guy. All right, if you don't have a notebook out, please get a notebook out.
Can we use the whiteboard or?
No, I want it in your notes.
What's the right
Oh, yeah.
Right.
Okay, open the notebook.
Yeah, I'm just waiting. Something to write
You were waiting for what?
down. Something to write down.
This, write this down.
Other than that.
Maybe the date, maybe a title like Transformations.
Something like that.
So, my general question, when I change A, what does that do to the function? Does it move down? Or moves up? Okay, first of all, I should point out F stands for some function, any function you can think of. So, could be trig, could be x squared, could be any function at all. This is saying whatever the function you chose, if you put a on the front of it, and I chose to give you an example with sine, because you've seen these in Algebra 2 last year. Rylan, what does it do?
Stretches it vertically.
Okay, so that 3 for a sine function makes the amplitude 3. It stretches it vertically, makes the wave 3 units high instead of 1 unit high. So that a, if you change a to whatever function, on whatever function, it's a vertical stretch. Okay, if it's 1/3, then it's a vertical shrink. Okay, yeah? So if the number is less than 1, it's going to get smaller instead of bigger. Yeah?
Yeah.
Okay. And B, I am not talking about B right now when we get to trig, like more involved. You guys did not change B in Algebra 2 last year, and we will in here. And explaining what that does is not going to work right now. So we are just skipping B. Rylan is okay with that. What does changing the C do?
Horizontal shift.
Horizontal shift. So
Right.
this one would make this specific example would make it move right.
So that means G would probably be up and down.
Yes. And it doesn't matter what the function is. If I say, here's this natural log function, don't know what that is, but if I say natural log function plus 7, whatever it was, make all the y values higher by 7. This example, does it move up or down?
Down.
How many?
Down 4, down 4.
Okay. Natalie, you've given it a look. Question?
No, I just didn't see it says vertical stretch. I was confused by what it is.
Okay, so, and So this one, it's 3 times taller
Yeah.
versus if it's 1/3, okay, then it's a shrink. I didn't write them both. Are you okay that I didn't write them both? George, I'm getting lazy. It's after 2, barely. So, my hope was that you guys would remember kind of what these guys do. And that if you can graph the parent function. Do you guys know what y = 1/x looks like? Can you erase the whiteboards and draw it and see what, your group, what does it look like? Which, by the way, if you flip it over, the grid is already there. See, look, there's a grid on the back of these. You don't have to use the back. That's what, if you've already got it.
Just like a box with
Let's see what it looks like. What was, oh, yeah.
Let me see. Mirna, what do you guys have?
With the arrows.
Okay.
I think it's easier.
So people are changing their mind. They're like, is it 2 things or 1 thing? Okay. Group 1, group 2, group 3, group 4, 5. So, Garrison, what do you guys have? So does it have 2 swoops or 1?
Depends.
This specific one. So it doesn't depend on anything. I'm saying this one. Is it 2 swoops or 1? All of you have this drawn. Great. Does it have a tail? Yes. Is it a happy tail or a down tail? Down tail. Okay. All right. So, my goal today is to remind you that you have heard of asymptotes before. There are 2 kinds of asymptotes. Well, 3, but we're going to do 2 today. Yeah. Friday. Why? What's wrong with them? Oh my goodness. Oh my goodness. Call your senator.
Would this be an odd function?
This is an odd function. You can turn it upside down and see the same thing. See, watch, look. Ha, ha. Okay, maybe it's just me, but it sort of looks the same.
No, you're right, yeah. But if there was just one, just say if there was one on the top, would that be
Okay,
either?
all right. So, here's what we need to get through. So there's vertical and horizontal asymptotes. We never finished that part of the thing. So this one, I just asked you guys, and you drew it. It's got that. There is a horizontal asymptote of y = 0 and a vertical asymptote of x = 0. Looking at this equation, looking at the denominator, where do I have a divide by 0 problem? X = 0. That, in this case, made a vertical asymptote. And I'm going to remind you of what you did in Algebra 2 to find the horizontal asymptotes, but we'll talk about that on the next slide. What's the end behavior? The end behavior of this, 0 and 0 on the other side, that is the value of y = your horizontal. Now, when we talked about this just on the last slide, what does that -2 do? Does it shift it left, right, up, or down? To the right, 2. Go team table 5. Yes. So the vertical asymptote is no longer at 0. Where is the vertical asymptote? Where this thing equals 0, which is at x = 2. So the goes there. Did the horizontal asymptote change? Or is it the same height? Same height of y = 0.
It just moved 2 places to the right.
It just moved 2 places to the right. That's all. So I was hoping to remind you, like, hey, these transformations, you've heard of them. Does it move left or right? Does it move up or down, or does it stretch? Okay, this one, hopefully you know. This one it moved to the right to. What does the second one do? Up to. So vertical asymptote, where that denominator is 0. Horizontal asymptote, well, the horizontal, which we'll do on the next slide, is 0 there, but then add 2 more. So that's the whole thing shifted up to. Yes, Jonah?
So, if there were, just say there was just one, right? Just one thing?
Just
Is
one
that
thing.
the odd, even, or neither? Just
So-
one, like on the top right, just one.
Okay, so this one, odd. This one, neither. Can't turn it upside down, can't do the butterfly
So that
fold.
one's.
This
that-
one, neither. Turn it upside down, this is down here. Folded it over, it doesn't work. So the second and the third one are no symmetries. Okay. Ready for the yay, asymptotes, horizontal asymptotes, woo. Oh, sorry, there's the graphs. All right. Ready? Top heavy, bottom heavy equal. Have you guys heard of this from algebra 2?
No.
Lie like rugs.
I ain't never heard of it.
Okay, well, here it is. Horizontal asymptote is there a line that the function's gonna approach at one end of infinity or the other? And they have been lying to you. Do you know that the function's allowed to cross the horizontal asymptote? What? Yeah, it can, it does, it will. It's not a violation. Let me show you if I can find Desmos again. Here's my favorite example. So as I zoom out, as I go to super duper positive infinity or super duper negative infinity, doesn't it look like it's going to like 0? So the end behavior, 0.11, that doesn't look like it's, come on. He's like, no. But look, when it was young, it had its wild, crazy teenage years and across the asymptote all over the place, so much so that it's colored in. Touchy, 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 all over. And then it settled down, bought a house, got a dog, and rode off into the sunset. Usually I say, and then he died, but you guys don't like that part, so fine. He doesn't die. He's just living really happy with his dog. So it's allowed to cross the horizontal asymptote. Or cat, or llama, or hedgehog, I don't know. People, there's llama farms around here. Within 10 miles, there's a llama farm. Oh, sorry, 10 miles from my house.
We should do school field trip.
To the llama.
Hey, we'll do that stuff after.
I don't believe you. Okay, anyway. Yeah,
Are there any alpaca farms near?
there's an alpaca farm in north of Baltimore, so it's.
There is?
How do you know that?
How do I know that? I go there
Every weekend.
I don't go
We
there
should
every
do
weekend,
it.
but I have gone there to feed them.
Well, we'll do some math stuff on the way.
Because, you know, why not?
How many?
How many alpacas are in a farm? How many
That
farms?
was a while ago, I don't know how many they have now. I don't want to think of the demise of
Oh.
those llamas. Okay, so, but really, these things. There's 3 kinds of functions you need to work with to figure out what kind of horizontal asymptotes it's got. So one kind of function is bottom heavy. Can you copy the function down and I will explain what I mean by bottom heavy.
more X's in the bottom?
Okay, yes, excellent, thank you very much. He says because there's more X's, and I should clarify, the highest exponent anywhere in the function is in the bottom. So, yeah,
So the highest exponent determines if it's top heavy or bottom.
the highest exponent determines if it's top heavy or bottom heavy, yes. So that there's an x cubed in the bottom compared to an x to the first up top. The horizontal asymptote is gonna be y equals 0. It will eventually ride off into the sunset at 0 with its house and its dog and llamas and hedgehogs, all the farm. Noah, he can come too. Joaquin, what?
You're also stuck on that pet llama thing.
I have a friend that has a llama obsession.
Is it you?
No, no, I have to take care of her animals when she goes to take
You
care of
take care of ours.
Is it pet llama?
No, it's cats from the Andes and one from Rome. The one from Egypt died.
Oh.
Oh my god.
Wait, was it one of the hairless cats?
No, it was not hairless cat.
Okay.
Hey, Reese,
Yeah,
Reese,
we
don't
are.
Not so much on the cats, bro.
Okay.
The
All
one
right,
cat.
sorry. Asymptote, sorry. Okay, top heavy. Why am I calling this one top heavy?
Because there's a.
A lot of exponent.
A lot of exponent up there. Yeah.
But would it be because
My bad game.
x to the fifth?
It's because that exponent, x to the fifth, is bigger than the x squared in the denominator, all right? And when it's top heavy, do you remember what it was from algebra 2?
I forgot, was it the vertical asymptotes?
No, we're gonna do vertical asymptotes in about a split second, but,
Is it 1? Or is that equal?
okay. If it's top heavy, we don't have, no horizontal asymptote. So if it's bottom heavy, y equals 0. If it's top heavy, ain't got no horizontal asymptote.
Wait, if it's bottom heavy, x equals 0?
Y
under
equals,
that. I can read.
it's a big difference. Y equals are these flat lines like this, horizontal. X equals go like, yep. Yeah. Do any of you remember?
No.
No.
I did not do that. You have too much
Okay,
faith
wait,
in this. Yeah.
I didn't have it. I had a social
We're doing stuff.
like my semester.
Every day. You really do.
That's
Wait, why would
Okay.
people think, why would that be equal? Because isn't there like an x, isn't
Okay.
there a cube? to the fifth?
Okay, what we're checking is the highest exponent. Is the highest exponent the same on the top as it is on the bottom?
Yeah.
Yes. The highest exponent on the top is the same as the one on the bottom, so what's the asymptote going to be? It's not y equals 1.
2?
Why do you get 2?
I don't know.
I don't know.
Yes.
Just pulled it out of nowhere.
Yes.
Love that. So if they're equal, take the coefficient of the top.
Oh, I was right.
Yeah, but you didn't know why.
No, I didn't.
So top heavy, bottom heavy, equal. If it's top heavy, ain't got no horizontal asymptote. If it's bottom heavy, it's y equals 0. Okay? All right. Underneath the second one, there's the fancy tricky ones. Okay.
Oh, God.
So, one thing,
Bottom.
this one is bottom heavy. Some people are looking at just at the coefficient. The 8 is bigger, but the exponent is what I'm looking for. So this still bottom heavy, it's going to be a y equals 0. Okay? And the example y equals 1 over x that we started with, bottom heavy, the horizontal asymptote is going to be y equals 0. Huh?
Isn't, don't they both have an exponent of 1?
In this?
I'm actually stupid, never mind.
It's late in the day. All right.
Oh.
Oh, oh my.
Why so many X's?
How about
Oh, great heavens.
Put 'em on.
It's top.
It's on what?
So what are we gonna do with it?
It's top heavy.
It's top heavy. Why?
Put 'em on.
15 isn't big enough. Oh, she's so clever. So I wrote it mean. Those of you who are taking the SAT next week,
What?
like, I wrote it so that the 15 and the 17, you'd be like, oh, it's bottom heavy. But Alexandra looked far enough along to be like, the highest exponent is to the 21st.
Would it still be no answer? Would it still be undefined?
There is still no horizontal asymptote. Okay, again, I warned you, these are the fancy ones.
There's 2 sevens.
2 sevenths?
And 2 5s.
Yeah.
Yeah, you wait.
And
It is
some
not 2
sevens.
sevenths.
5 both. Wait, why is it not 2 sevens?
It is not 2 sevenths. It is not 2/3.
Why is it?
2?
Minus 2/3.
Oh, negative 2/3. And not just negative 2/3, you need the y equals. Highest exponent,
Oh.
take the coefficient, which keeps the sign that was attached to it. Okay? Yep.
The 2 5s mean anything?
Okay, so I left these here to confuse you, or to trick you, really. Not to confuse you, but to trick you, like, oh, they're equal, but you gotta look through all of the stuff that's there, all the terms. Oh, well, you know, best that I do it here rather than on the test, yeah?
Oh, okay, yeah.
And calculus, they get this wrong. Micah? Lori? No? Okay. Yeah.
So, so we gotta, divide the ones that have the highest exponent together?
So the way to figure out the horizontal asymptotes, again, this is a review of algebra 2. Is it bottom heavy? That's the easiest one, because bottom heavy, y equals 0. And don't just tell me 0, I need the y equals, it needs to be the equation of a line. If it's top heavy, no horizontal asymptote, don't have it. Right? Then if they're equal, the highest exponent on the top and highest exponent on the bottom, take the coefficients in front of them and it's y equals whatever that is. Okay? That's horizontal. Now we need to do vertical.
Oh no.
Your homework is on Delta Math, please do it. I'm gonna check. So first question here, with your group, like write these down, write these 2 examples down. A, B,
C, D, E, F, G.
nope, just A and B. What's the domain? Now write something. Sorry?
What's the domain?
This is do it now work. Homework is on Delta Math.
That's.
Yep,
For the domain.
okay, you have it already. What's the domain of the first one?
Negative infinity to -9, -9.
No.
Close, but-
3 to 3, to -3, -3 to 3 to infinity.
Okay, so Ethan factored this and said, okay, x can't be 3 or -3. All right, that's back from our piecewise function days. And our goal is in a week and a half, 2 weeks, you will be able to graph these without a calculator and know exactly what it looks like. So here's a couple of hints on this one right now. These places where he identified, I gotta kick these guys out, 3 and the -3, on the graph, this x plus 3 equals 0, I'm gonna have a vertical asymptote at x equals -3. This guy right here. That other factor, it's gonna be a vertical asymptote here. What is the horizontal asymptote of this equation?
Y equals 0.
Y equals 0, because it's bottom heavy. Okay, and then here it's a little tedious, but it's gonna be some kind of swoopy this way, maybe this way. There's stuff that I can check. and then there's funny business in between. But I have some ideas of what the function's gonna do. What pieces get thrown out of here?
-3.
Jordy, how does it factor?
X plus 4 and x minus 3.
X plus 4 and x minus 3, so we need to throw out -4 and +3. What's the horizontal asymptote, Lily, on that one?
The horizontal.
Horizontal. Is it top heavy, bottom heavy, or equal?
Fine.
Bottom heavy, so what's the horizontal asymptote, or don't I have one?
Y equals 0.
Y equals 0. Okay, so to show you what they actually look like,
Oh,
Ew.
horizontal asymptote verticals at x equals +3 and x equals -4. X equals +3, x equals -3. Okay. In here,
you have to graph this out.
okay, so what Keno's about to say. Honors, they have to do 2 vertical asymptotes. You guys do not. So pretty much all of what you guys are gonna graph are gonna be shifts of this. Yeah,
Is the first one an even function?
it is not. It's got this funny sideways smile. It doesn't fold. It's
That would be an
it's an either. It's just got a little bit of a dip on one side.
But if it did, it would be even.
If it was
Is that there
smooth,
again?
sorry,
Why is that there again?
why is what there?
Because
Oh, it just happens.
Oh, okay.
And are you guys gonna be responsible for graphing that lumpy thing in the middle? No.
thank God.
So, if you can still find the domain, like what's kicked out of the domain, that is the first step to identifying, like, hey, for these guys, the vertical asymptotes are where, solve for this when it's 0. X equals -3 and x equals +3. Those are the equations for your vertical asymptotes. Yeah, kind of, sort of. Hi, Ethan, how you doing?
Good.
Long ass day, huh? Good times. Good that I'm being recorded. Awesome. Awesome sauce. Okay. So, Garrison, you were like, are we gonna have to do holes? Yeah, they might be, they might happen.
This is equal.
So, okay, yeah. Let's look at these. Horizontal asymptote is not just 2,
Y is equal.
y is equal to 2. So horizontal asymptote, looking at it. Joaquin saw right away the exponents are equal, and I think it was Nahum that said 2. It's 2. Where's the vertical asymptote, or do I not have one?
X equals
X equals 5, thank you. So, if you have to graph these, which you will have to do, that is your next quiz, is graphing these. The way we do this, all right, I'm gonna move that horizontal asymptote. It's kind of like the x-axis got moved up 2 units. And then there's my vertical. And then I'm gonna, how do I find intercepts, x and y intercepts? When it hits the y-axis, what's the x value? What's the x value all along here? X equals 0. So when I put in x equals 0, what comes out? Plug in 0, I get 0 divided by -5. What's 0 divided by -5?
0.
0. Okay, so it's gonna go through the origin, so there's a dot there. And where's it gonna hit the x-axis when y is 0, and that's gonna happen at that too. Okay, so I'm gonna now pick a point, x equals 4. Putting in 4, I get 8 divided by -1. It's down here. Those asymptotes are like force fields. The function's gonna go through the two dots that I just calculated, and the line's gonna go towards the asymptotes, yeah.
Do you only have to graph two?
You should do 2 or 3. This side I don't have anybody, so I'm gonna put in 6. So I get 12 over 1. Okay, that point's way up here somewhere. And 7. Putting in 7, I get 14 divided by 2. 7, so the function's gonna look like that. So, just checking, like, is this crazy? Is that absolutely insane?
No.
Because if you can look at this and say, top heavy, bottom heavy equal, does it have a horizontal asymptote? And then draw that in, and then look at the denominator, where is that guy undefined? Where do I have a divide by 0 problem? Well, when x is 5. Draw the little the fancy word for it. And then get a couple actual coordinates, don't just eyeball it. But tomorrow we will be doing stuff like this. Today, on Delta Math, you just need to identify what are the asymptotes, horizontal and vertical. All right.